All right, well, we're not quite up to full strength. I think some people are still on spring break. I think all of us wish we were still on spring break, right? Haven't heard that sound in a while. All right, that's the, what, Windows 98? No. Yeah. All right, well, today we're going to be talking about budget limitations and capital rationing. Maybe the only reason you came today is you're hoping to get your exam back, but you're not going to get it back till Wednesday at the earliest. I was sitting on a plane yesterday. I had a 13-hour flight. Yeah, so you think I'd be able to grade an exam on a 13-hour flight, but the problem is that they don't have internet access on that flight, so I wasn't able to access any of the stuff that was uploaded. So anyway, that's my excuse. You'll get your exams Wednesday. Today we're going to be talking about budget limitations and capital rationing, so let's go ahead and get into that. But first, this homework assignment 12 is due on Friday, and you will, after today's in-class exercise, be able to solve most, if not all, of those problems. It's only 3 problems, so it shouldn't be too bad, get you back into the swing of things. All right. Capital rationing acknowledges the idea that we don't have unlimited money, and that when you're selecting projects that aren't mutually exclusive, you have to identify the combination of projects that's going to yield the highest profits. So we're back to talking about projects that are profitable. Just to revisit where we've been, remember that we started off talking about some techniques for analyzing, should I choose option A or option B, figuring out different ways to analyze mutually exclusive alternatives for which one is best. Then we talked about projects that maybe don't generate profits, cost-only alternatives. And benefit cost analysis was one way we discussed compare options there. Another was cost effectiveness analysis. So what we're talking about today is back to the idea of projects that are profitable, but then the projects aren't mutually exclusive, which means you can choose more than one of them. So every organization has limits on the available of investment capital, and so just as an illustration, these are some pictures of projects. 2 of the 3 were completed. These are projects that were in Dubai. That's where I was over spring break. And while I was there, I saw the Palm Island. While I was there, I saw the Burj Khalifa. But I did not see this underwater hotel that was proposed because it was never built. And the reason why is back in 2008, there was a big economic crisis. It was a worldwide kind of debt crisis where a lot of projects, especially those that were related to real estate and tourism, had to be canceled because suddenly a bunch of banks started to fail. And these 2 projects, the Palm and the Burj Khalifa, both of them were already pretty close to being completed before that budget crisis hit. But the underwater hotel that never quite got off the ground, or I guess under the water, so to speak, they had to limit the projects that were completed because they ran out of money. So a capital budgeting study is a process of going through and identifying a cash flow estimate for every project that you have as an alternative, and then also looking at the initial investment price for each alternative, and then trying different permutations of projects. In the case of 3 projects, what are all the different options that you could do? Well, you could do none of them, so that's one option. And then you could just choose one of the options individually, so then that takes our total up to 4 alternatives to consider. You could do all 3 projects, and so that gives us a 5th. But then you could also do 2 out of the 3. It could be the first 2, it could be a project 1 and 3, it could be project 2 and 3. So you see that there's lots of different possible combinations, and what we're going to do today is look at all the different possible combinations and find out how much profit could we get from each of those combinations. And the assumptions that we'll go through is that a project is either fully funded and accepted or rejected, that It would be even more degrees of freedom and even more options that we'd have to consider if we had the idea of partial funding of a project. And so to eliminate even more possibilities, we'll just make it either yes, it happens and the cash flow occurs as we project, or a project is rejected and we don't get that cash flow. The basic idea is to analyze how budgetary constraints can restrict the investment and trying to find out, based on that limitation on the budget, which of the options we should select in order to maximize the return on the investment. And so picking the combination that gives you the highest present worth of all the combinations is the decision criteria that you're going to apply. You choose the bundle of options that maximizes the present worth of all the projects. Here's a diagram that comes from our textbook that kind of summarizes what we're going to be applying. And what this diagram says is, just as an illustration, there's 3 alternatives. And they each require a different amount of initial investment. And each one of them is going to have some different lifetime, different cash flow consequence of the project. But what we can do to compare all of these alternatives in a consistent way, since they have different useful lives, take everything to the present. And then we know that there's some limit on how much we can initially spend. And so we may not be able to accept all of the options. We just have to find out, for the limited amount of money that's available, which combination of alternatives is going to generate the most revenue. So our objective is to maximize the present worth of the value that's being selected. And so we're not going to do a rate of return analysis, because these are going to have different useful lives. We're going to use present worth analysis instead, because that's a way for us to account for the differences in time value. Okay, so these are the 4 combinations that we're going to consider for today's in-class exercise. But the first thing I want to share with you is how you can know how many bundles there are. This 2 to the power of m, where m is the number of options that you've got available, that will tell you how many bundles there are. And by the way, what we assume is that bundle AB, just as an illustration, AB is the same thing as BA. And so just by rearranging the order that you label them, that doesn't create a new set of alternatives. It just means that you're doing both of those if it's AB, and it's the same thing if it's BA. All right, so you can see that I've listed here 4 different project alternatives, A, B, C, and D. And there are 2 to the m possible bundles. And so what that means is it's 2 to the 4th is how many options that we've got when we're trying to figure out how many bundles there are. So that's 2 times 2 times 2 times 2. So that gives us 4 times 2, which is 8 times 2, which is 16. So there should be 16 different possible combinations. So I'm going to hand out the in-class exercise, and what I'd like you to do is try and write down what they all are. And it's kind of funny, even when you know that there should be 16, sometimes it can be a little bit tricky to identify and write them all down. So it's good practice. A couple more. All right. So first thing you can do, part A, let's find out how many bundles there are. I already did that on the whiteboard. There's 16. Write down which the bundles are, like by name, A, B, C, D, that's one of the bundles, and so on. Once you've got those bundles written down, then using Excel, if you have it available, but you don't have to necessarily use Excel, in part B, I'd like you to calculate what's the initial investment required for each one. We're going to assume that our budget limit is $23,500. So that means you can spend that amount. That amount is a yes, but anything more isn't feasible. So identify how many of the 16 combinations are feasible based on the budget limit of $23,500. At the bottom of the page, I tell you some possible column titles that could be useful, like the bundle number, the cost, the annual net cash flow, present worth of the bundle. That's for part 2. If you're doing it on Excel for part 1, then what I'd suggest as the title, maybe the column headers that you'd have in your spreadsheet would be the bundle number, and the next column would be the combination. And so by combination I mean bundle number 1 is the combination do nothing. That's one of the options out of the 16. Bundle number 2 is maybe A, B, C, D, E. Now that's a possible combination, but your next column that you're going to have is cost. And it's based on the cost that the last column is going to be if it's possible or not. I maybe should have shifted that over to the left. I won't write on the paint. So column number 1 is the bundle, column number 2 is what's the combination, column 3 is the cost, and the 4th column is possible, meaning is the total cost for that package of alternatives less than the limit of $23,500. So in the case of A, B, C, oh, there's not an E, A, B, C, D, then the total cost would be the sum of all of those initial investments, and that's going to be more than $23,000. So it would be no, not possible for the bundle A, B, C, D. Any questions about what you need to do for this part 1? All right, I'm sure everybody here's, well, no, I guess some people are currently in 111, right? But most of you have taken it already and probably remember the if function in Excel. Let me give you a quick refresher. Rather than me manually having to say yes or no for whether it's possible, I mean, I could do that, and 16 rows wouldn't necessarily be that exhausting. If it was 16,000 rows, you wouldn't want to have to do that yourself, and it's easy to make mistakes. And so let's see if we can use the if function to have it automatically compare the budget limit to the cost and decide if it's possible. So equals if, and now it starts to give us the prompt. Logical test. So what we're going to do is we want it to set up a logical test so that if the cost is greater than the limit, it will say no. And if the cost is less than the limit, it will say yes. But what makes things a little bit tricky is the fact that, for whatever reason, I've chose to put the negative sign in here. I guess if we just took it for granted that these are costs, I wouldn't necessarily have to put the minus sign there. But I guess if we were later on going to use this to calculate present worths, which actually we are doing, so maybe it's good to leave the costs as a negative sign. All right, so the logical test is going to be if the cost is less than the limit, then the answer is no. But if the cost is less than that, so if it's not true, then it's yes. So let me just think for a second. Is that the correct logical test? Because by less than, what I mean is more negative. So for instance, I want it to say no for 39,000, for negative 39,000, because negative 39,000, that's too much money. Our limit's 12,500. So if this is less than that, then it'll say no because it's not possible. But if it's not less than that, it'll say yes. And you'll notice we do have one bundle CD, that's right on the edge. And so bundle CD is possible. And so it should say yes to that if we've set up the logical test correctly. So it's saying yes to do nothing because 0 isn't more negative than 23,500. The negative 23,500. Yes, I better do that. Lock the reference so that it doesn't start looking down. All right, so when I drag that, it applies the same logic to everything else, and the one I was worried about was CD because that's right on the border there, and it looks like it did correctly distinguish. It knows that the negative 23,500 is acceptable. That's within the budget limit, but then everything else was too costly below that. And it even picked out this one AD. AD would also be too much. It's a no. So let me go back to the logical test. And we could have done that a variety of different ways. I didn't have to set it up as less than. I could have done greater than or equal to, and then made it yes/no. You know, this is the negative. If it's true, then it's saying no. Let's see if I could do it the other way around. The other way of doing it would be if C4 is greater than or equal to, let's see, greater than or equal to, yeah, greater than or equal to this, and I'll lock the reference now, then, so greater than is going to be not as negative, so then it should be yes, and then if that isn't true, then it should say no, with an exclamation mark. All right, so now I apply that down through all of them. It looks like it still works. So you're either trying to identify the ones that are not possible, which was the first case, and then everything else by default is possible, or the if statement that I've set up here, it's identifying the ones that are a yes, and then the conditional, if it hasn't already triggered the yes, then it'll trigger no instead. So that's part one of just preparing what are the bundles, what are their costs, and the initial screening of what's possible. So right off the bat, what we're doing is we're eliminating the options that we don't want to know the present worth for because we can't afford it anyway. So there's no reason to calculate the present worth of bundle A, B, C, D because it's outside the budget. And later on, we're going to have to pick the highest present worth, but it has to be the highest present worth among the options that are within the budget limit. So it's better just to screen out the ones that aren't possible from the very beginning. So here in step 2, selection, what we assume is some annual net cash flow. These original investment amounts are the same as they were before. But now what we know is that the project lasts for 8 years. We've got a MAR of 12%, and we want to know which of these 16 bundles that we identified as possible, well, they're not all possible, which of the remaining bundles that are within the limit should be selected. Now, on the bottom of the page, I told you what I suggest the column headers ought to be. Let me set up that next part here. So what we're going to have is, in part 2, this was part 1. Over here in part 2, we're going to have our MAR, which in our case is 12%. We're going to have N, the number of years of each project is 8. Now, it doesn't necessarily have to be the same number of years. We can still assemble bundles that have different useful lives as long as we take everything to the present. We still have this budget limit of negative $23,500. But what we have to now do is assemble a list of bundles, the cost, annual net cash flow, and then finally the present worth of the bundle. All right, so in this list, only put the ones that are possible, and then we're going to calculate the present worth by taking the revenue that's mentioned. So we've got this annual net cash flow. That's the revenue minus the expenses. This is the leftover profits that are justifying the initial investment. So here in the present worth column, you're going to take the annual net cash flow to the present and combine it with the initial cost. So put those two things together in the one cell, and then we're going to try and identify which bundle that's remaining as a possibility gives us the highest present worth. All right, so which option is best? Out of the bundles that we can afford, the best thing for us to do is... Oh, the screen's off. How did that happen? Looks like bundle AC is our best alternative. Wait for it. The screen will be right up. What we have to remember is that when we have the annual net cash flow, that's the revenue amounts that will occur 8 times for each alternative. So let's go through the process here. What I did was I only included the rows that were possible. So any one of these that wasn't possible, I didn't copy over to our analysis in part 2. So we've got the cost, the annual net cash flow, and for the combinations, the cost is the combined expense of both options. The annual net cash flow is the same. You're combining the net cash flow from each individual alternative. So for the present worth, the function that we need to use is a PV function will take these annual net cash flows back to the present. And what goes inside the PV function is our reference to the interest rate. And we lock that reference to the interest rate so that when we drag the function down, it isn't losing track of it. Same thing, lock the reference to n in the second field here for NPER, the number of periods. And then the annual net cash flow amount, that goes in the third field. That's the payment function that we've skipped over so many times in the past. This time we're not skipping over it because these annual amounts are recurring n times. And so we want to know what's the present value of n occurrences of this annual net cash flow amount. So that's all that goes inside the PV function. We add the cost external to the PV function because that's an amount that's already at the present. So you can see that the highest of those is this option AC. And maybe to make it more clear which one is best, we could highlight all of the options. And here there's conditional formatting. Under the Home tab, Conditional Formatting, I'm going to create a new rule. And maybe what I want to do is format only the top or bottom ranked value. So let me have it be the top one value, and then my format is going to be that I make it bold. Okay. And then when I click OK, it's going to go through all of these options and pick out of the range that I have selected which is the top one amount, and it'll make it bold. So it can just make your option a little bit more visible. Another approach to help find which one is the highest is do equals max, and then highlight this range, and then it'll tell you what's the maximum amount. And so then when you go hunting through the list, you can know what you're looking for out of the range, which amount was the greatest. So the answer to our analysis, what we did here was we created these bundles, and then we analyzed with capital rationing which of them is possible, and then out of the remaining options that are possible, which one is the most profitable. And so our company should only spend $18,500, even though some of these other options get closer to that budget limit. They don't necessarily yield the highest profit. So what our company should do, if the budget limit's $23,500, is option A and option C. All right, so having seen and done that in-class exercise, I think that you've got a good start to work on the homework assignment. Of course, I've heard some of you talking about the project, and I'm glad to hear that you've spent some of your spring break thinking about the project. And if you've got any questions on that, please feel free to stop by during my office hours. They're generally pretty quiet. And I'll get those exams to you on Wednesday, so I'll see you then. Mm-hmm.